Okay, welcome back to Module 7 of the Farmer Pesticide Core course. This is our last module for the Farmer Pesticide Core aspect of the certificate. So we're going to be talking about pesticide application and equipment calibration. So in this module, we'll talk about selecting the correct equipment to apply pesticides in a safe manner, minimize off-target applications, and calculate the correct pesticide dose, and then complete essential maintenance calibrations. Pesticide application, initial critical stages of pesticide application. It's important to correctly identify the pest problem to ensure treatment is required. And what type of treatment? You'll select the safest, most appropriate product for the job. Handle products safely during transport and storage. Have necessary safety equipment on hand. Read and understand the label. Know if crop is at the correct stage for treatment. Make sure you have the right application equipment and it works properly. And then be prepared to deal with any problems or emergencies that could arise. So selecting your equipment. Choose the application equipment that applies the pesticide uniformly to the desired pest at the correct rate and does not contaminate non-target sites. There's a variety of application equipment available for applying pesticides, so it's important to know the types and characteristics of each. Those of you who have big farm operations, I mean, you have your equipment, you know what you're using and what's effective for you. In regards to fumigation, which is why a lot of you are here, there are certain types of equipment that you'll be needing to use in order to apply the fumigant. You can have a look in your book in Module 7 on pages 2 and 3. I'm not going to go through it. It's something you can look at on your own while you're going through the book and doing the exercises. All sprayers consist of basic components that perform standard functions. Okay, tanks, they hold and carry the chemical solution. Your pumps, pressure controls, agitators, and filters meter the correct quantity of pesticide, control pressure and volume, and prevent plugging. Booms and nozzles distribute the material accurately in a uniform pattern. And then on page 4, very simplistic diagram of a spray system. Of course, now there'd be all kinds of computerized and GPS and things like that would be included in some of these more sophisticated spray systems. Reduce personal and environmental risks of sprayers. So understand sprayer components and ensure yours are adequate. Follow the equipment manufacturer's instructions. Follow instructions on the pesticide label, and then calibrate for uniformity and rate of application. If you look through your book, starting on page 5, 7-5, there's a number of nozzles that are out there and available. I'm going to talk a little bit about the Venturi nozzle or air induction nozzle. So the Venturi nozzle draws air into the spray stream to produce larger, more uniform droplets that are much less subject to drift. Now, I have this underlined because drift is a major problem, and when we're using herbicides and whatnot, it's important that drift be minimal. And so the Venturi nozzle is probably one of your best nozzles to help control drift. Um, it works best at relatively high pressures. Depending on the tip used, it can produce spray patterns for a variety of purposes. And it's commonly, as I said, used where spray drift is a concern. We live in southern Alberta. I think drift is always a concern in this part of the country. So here's just some types of material that nozzles can be made of: ceramic, stainless steel, polymers, brass. I'm not going to get into all these different types and which are better. So anyway, there's the chart on that. So you're going to select your nozzles carefully because they do affect the performance and operation cost. Replace nozzles when output varies by more than 5% of manufacturer's specifications. Softer nozzle materials, higher pressures, and more abrasive formulations all result in more rapid nozzle wear. So it's important that you're choosing the right nozzles, that you're inspecting the nozzles regularly so that they're functioning correctly and fulfilling what you need them to do. Sprayer design for operator safety. Lots of different designs and accessories that improve environmental and operator safety during spraying. Remote control, monitoring equipment, GPS guidance make application accurate and convenient while keeping the operator away from the spray or the pressure lines which could burst or leak. Safe field operations, so your water source. So we did talk a little bit about it earlier. If you can fill on site, that's the best. So hauling water to the sprayer using a nurse tank is the best way to prevent contamination of any water source. This ensures that you do not contaminate your water source by water siphoning from the spray tank back to the water source, the tank overflowing, pesticide spilling near or into a water source or running down the sides of containers, dripping nozzles or leaks, or pesticide washing off sprayers, tanks, or trucks. Transportation to the field. Fill the sprayer in the field to be sprayed, if possible. By adding chemical in the field, you decrease the chance of spilling chemical into the environment. A spill during transport would be hard to contain and clean. Weather conditions. Consider your air temperature, relative humidity, and wind speed when you apply pesticides. Pesticide drift can cause damage to crops, beneficial species, human health, and the environment. The best performance is obtained with light wind, high humidity, and moderate temperature. Spray drift. So very small spray droplets or vapor always drift downward. Some drift is inevitable, which is one reason for buffer zones. Spraying in windy conditions presents the greatest hazard. Like I said, we live in southern Alberta. We often have wind. You can minimize wind drift of airborne pesticides towards nearby water crops, livestock, and residential areas by doing the following. Apply when the wind speeds are low, less than 16 kilometers an hour if possible. Apply when relative humidity is greater than 40%. Use the Venturi nozzles with proper boom pressure. Reduce nozzle height and boom pressure while still maintaining correct application rates. Use coarse spray droplets. Apply when air temperature is below 30 degrees Celsius. Use spray boom shrouds or cones. Minimize drift damage by spraying downwind of sensitive areas. Vapor drift. Minimize vapor drift by select low volatile pesticides. Apply pesticides when weather conditions do not favor evaporation. Properly seal bins if you're using aluminum phosphide. Seal ground squirrel burrows when using aluminum phosphide, and avoid atmospheric inversions. Sprayer maintenance practices. So improper or lack of maintenance can result in accidents, spills, personal exposure to pesticides, contamination of the environment, lost time, cost for replacement parts and repair, and then crop loss due to spray damage or lack of pest control. So on page 10, there's kind of a checklist here. It's got a daily maintenance and seasonal maintenance. So you can go through that and see what should be maintained on a daily basis and what needs to be checked on a seasonal basis. So granular pesticide application equipment. Methods of granular application. So there's broadcasting, even distribution over the ground surface, spot treatment, banded, furrow application or side dressing, soil incorporation, drilling or soil injection. The biggest problem with granulars is obtaining an even spread pattern. Spray pattern uniformity. So variables that affect spray pattern uniformity across the swath width includes your nozzle height, your nozzle fan angle, nozzle type, nozzle pressure, nozzle size, nozzle material, and manufacturer. Equipment calibration. Calibration is a procedure for checking and adjusting the delivery rate of the application equipment. Calibration ensures your application equipment delivers the correct amount of pesticide. That pesticide is spread uniformly over the target. Even if the correct amount is applied, good control is not always guaranteed. Control may be poor and may damage crop if application is patchy. Pre-calibration. So make sure to pre-calibrate your equipment by going through the pre-calibration checklist. It's on page 13 in module 7. So you're going to determine your travel speed. So from the label, find the volume of spray solution recommended in liters per hectare, liters per acre. Refer to the manufacturer's nozzle chart, tables 6 and 7. So these are on page 14 and 15 as an example of a nozzle chart that you might be familiar with. Check your speed in the field, refer to table 7, and then calculate the amount of pesticide and water to mix. So some simple math here. So sprayer tank capacity, let's say it holds 1,800 liters. You've read the label, and the label says to apply 40 liters an acre. You calculate acres covered per tank. So 1,800 liters divided by 40 liters an acre equals 45 acres per tank. Recommended application rate from the label says you need to apply at 0.6 liters an acre. So we know a tank will do 45 acres, so 0.6 times 45 is 27 liters. So in your 1,800 liter tank of water, you're going to have 27 liters of chemical. this breaks it down to, so now basically what you're going to do is you're going to do this calculation. We talked about it in an earlier module. You'll fill your tank half full, turn on your agitation if need be, add your 27 liters of chemical, and then refill or fill your tank up to the top. So this is just, you can do another exercise using this here, same math. So I'm hopefully by now you guys know how to figure that out in your equipment. So make sure you know how to do the math. That's very important. Changing output rates, large changes in your spray rate. You could change your nozzle size. If you have a large, if you need to make a large change, then you probably need to change your nozzle size rather than adjusting pressure. It's important that the proper pressure must be maintained to control drift and retain the proper spray pattern. Small changes in spray rate, I've got this in bold. The kind of sprayers that we use here, and our speed application rate is directly proportional to the speed. So the higher the speed, the lower the rate. The slower the speed, the higher rate. So if you have to make small changes, you can speed up a little or slow down a little. Other minor changes, if even less, you could adjust your pressure a little bit for losses in pressure between the pressure gauge and the nozzles, but do not change it more than 10% from the spec. And that is the end of Module 7 and the end of the farmer pesticide core component. So I encourage you, now that you've listened to all 7, you've listened to me yak for 7 modules. If you are required to write the test, if this is the first time you've done this course, I do encourage you to do the exercises at the end, because you will have to come in and write that exam in the office. So thank you for attending, and I'll see you in module 8, which is stored grain.